math wasn't exciting, people would
Yep.
people would not drop out of it or quit it. You know.
You're not going to quit. Have too much fun. Here we go.
I'm not gonna quit.
Factored trinomials. This is part 2. Listen, a trinomial, real fast. Again, we call it a trinomial because it has 3 parts. And when we have a trinomial, all right, that is not factorable. I look for the common factor. 1, 7, and 12 don't factor. X squared, x, no x's. Nothing to pull out. Then you say, since it's a trinomial of order 2, a quadratic formula, we can factor this. X times x makes x squared. And we can start going to this, especially when the coefficient is 1 on each of these x's. We can say, what are the factors, or what 2 numbers make a product of 12? And again, from yesterday, we said 1 and 12, 2 and 6, 3 and 4. I have to have one of those 3 sets. And the sets must sum to this number. And again, I picked positives to keep it easy today. So when I look for 7, 1 and 12 don't work, 2 and 6 don't work, 3 and 4 work. And that's factorable. That is a quick review of what it is. What students typically do wrong is when I give them problems like this. And then right away they see 3 terms. It is a trinomial. But what is the order of this equation?
12x and then...
No, I asked what the order is, and it's not 12x. The order is 3. We cannot factor an x cubed, all right? But look at the terms. X cubed, 7x squared, and 12x. What do you notice? What's common? X, all right? And like we've been doing, all right, as we've been doing here, if I pull an x out, take a look what happens. I get x times, and now I have a trinomial here, right? X squared, 7x, 12, same as the page before. And I can do this, right? And if I took the time to multiply this all out, all right, you would get that these are all equivalent. And again, this is factory. And we always look for a common term. All right? And what was common this time? X was common. It doesn't have to just be X. All right? It doesn't have to be X. It can be almost anything.
Hey, don't throw up.
Well, I'll just use one of them.
All right. All right, so everybody, what's the problem here again? We have something common, but there's a problem before that. It's out of order. Guys, take a look. X cubed, x squared, x. We have to be in descending power. All right? So, all right, it has to be in descending power. All right? So, when we get this, what are we going to factor out this time? Now, there is a shortcut here. If we're going to make it factorable, what do we need the lead term to be?
4x.
No. If we're going to factor this as a quadratic, doesn't the first term have to be x squared?
Oh, yeah.
So what do we have to pull?
4bx.
We have to pull out 4bx. All right, and if I do that, and be careful, what typically happens is people forget to bring the 4 out of the middle term, and they forget to bring the 4 out of the 80. And again, 4 times 20, it makes 80. What factors do we want to use here this time? Again, x squared, x, 20, nothing can be factored anymore. What times what makes 20?
4 and 5.
1 and 20.
1 and 20, which makes 21 or 19. That doesn't work. The next set is 2 and 10, right? 12 and 8. 4 and 5. 9 or 1. So the question is it plus 5 minus 4? Or is it minus 5 plus 4?
Minus 5 plus 4.
Minus 5 plus 4. Negative 5 times positive 4 is negative 20. Negative 5 plus 4 is negative 1. And I stress again, this only works, guys, when these coefficients are 1. There's a different set of rules we'll have to use when these are not 1 on the binomials, all right? So, one more. All right. Is there anything common factorable across these three?
No.
Nope. X, no, negative.
The negative sign. Right on. What do we need the lead term to be? X squared. If I need this lead term to be positive x squared, we're going to have to pull out the negative sign. And what does that do to all three terms inside the parentheses?
Positive.
Makes them all positive, changes all their signs. And again, what times what makes 4? 2 and 2. 2 plus 2 is?
4.
Okay, why is my last line wrong?
Because there's no negative.
There is no negative. It's got to come down. Also, we want to get used to what's x. Instead of writing x plus 2 times x plus 2, we should get used to doing x plus 2 quantity squared. All right, we're going to do some practice. Let me turn the camera off. Thank you.